In the shadows of forgotten legends, fear still breathes. Welcome to Peculiar Bong. Modern viewers often see ancient Egyptian monuments as works of divine perfection, but this pristine exterior hides a much messier history, one grounded in the human reality of trial and error. Around 2610 BCE, Pharaoh Sneferu initiated an ambitious architectural gamble. His goal was to construct the first massive, smooth-sided pyramid in human history. The design relied on a steep 51-degree slope. However, engineers placed the outer casing over a stepped core without a structural bond. This lack of integration triggered a catastrophic shear failure. Under its immense weight, the facade detached and slid violently down the structure. The Mitam Pyramid survives today as evidence of that miscalculation. It stands as a jagged, ruined tower rising from a massive mound of rubble. This disaster forced the ancient Egyptians to completely change their approach. To achieve eternity, they would have to move beyond ambition and embrace the rigid logic of the scientific method. Sneferu's engineers took the data from the Meidum collapse and applied it to their next project mid-construction. At the bent pyramid, the builders drastically reduced the slope angle halfway up. They were actively shifting the weight of the masonry to ensure load distribution and structural stability. Their final prototype, the red pyramid, utilized a mathematically sound 43-degree slope. This successful design provided the blueprint for the true, stable pyramid form. The stability and precision of the Great Pyramid of Giza were built on a foundation of these visible, costly engineering failures. Supporting a monument-building society required an immense agricultural output. In the desert, that meant learning to control the volatile cycle of the Nile. Through basin irrigation, engineers trapped floodwaters and rich silt on flat fields for 40 to 60 days. This simple system turned a seasonal flood into a reliable growing season. Survival eventually required predictive hydrology. The Egyptians needed to track the river's behavior with mathematical precision, leading to the invention of the Nilometer. Inside these stone wells, officials used a central octagonal column to track the river. They engraved seasonal water levels into the stone, creating an empirical record of the Nile's power. By recording this flood data over centuries, the state could predict future crop yields and engineer economic stability out of environmental chaos. Ensuring their civilization lasted meant conquering the natural degradation of organic and metallic matter. They formulated bronze by mixing copper and tin, creating an alloy that could resist structural corrosion for thousands of years. Their mastery of chemistry extended to the synthesis of inorganic pigments like Egyptian blue. This required precise stoichiometry, calculating the exact atomic ratios of copper, silica, and calcium. This same chemical rigor was applied to human biology. Through mummification, they used specific compounds to halt molecular decay and preserve the physical form. These were deliberate technological interventions. Every chemical feat was a calculated attempt to pause time and protect their history from erasure. A museum gallery holds more than just aesthetic objects. These artifacts are the surviving data points of a civilization-scale science experiment. The vivid condition of the paint and stone on these objects proves the ultimate effectiveness of their iterative methods. This longevity was earned through centuries of catastrophic collapses, meticulous data logging, and chemical trial and error. The ancient Egyptians succeeded as human problem solvers. By learning from their visible failures and refining their data, they engineered their own path to eternity.
Do not close your eyes. They are waiting for us.